goal really is to get to the point where you don't need that sitting next to you, that you've got the unit circle memorized, okay? And you can just rattle off the identities, you can rattle off the common angles, you can rattle off the x and y coordinates on the unit circle and all that sort of stuff. So this is 13.5, this is the next section in line. Would you write down unit right here? And we're just going to go through how to use the unit circle. Once you've got that in your head, there are so many things that you can just rattle off and know, oh, I know this, I know this, I know this. So it says what ordered pair represents each angle on the unit circle. Now, if you want to look at it, I'm okay with that. But what I'd prefer is that you stop and think about, hey, how did this stuff work again? So I'm going to write a 135-degree angle. I'm going to draw a reference triangle for that. And I'm going to remember that that angle right there is 45 degrees. And if that angle right there is 45 degrees, and this is on the unit circle, this is radical 2 over 2, and this is radical 2 over 2, okay? Now, I've made a tiny mistake here, and I made the same mistake yesterday, and you better not make this mistake, because people do this all the time because they're not paying attention to details. What is it?
That needs to be negative.
It does, because that represents the fact that we went to the left. So if it says what's the ordered pair that represents that, the ordered pair that represents that would be negative radical 2 over 2, comma, radical 2 over 2. That should match up with exactly what you see on your chart, does it? Okay, let's do the next one. 240 degrees. So 240 would be 90, 180, not quite 270, but about right there. So if I draw an angle right here, that is a 60-degree angle. Okay, wait just a second. So this is the big angle. This is the big side. So that must be radical 3 over 2. This must be 1/2. And since we went left, that would be negative, and we went down, that would be negative. So this is going to be negative 1/2, comma, negative radical 3 over 2. Good there? Do I see any puzzled looks? D? This guy right here?
Yeah, like I don't understand how we got that from the graph.
Okay, do you remember the special right triangles of 45, 45, 90? If this is 1, how do you go from a hypotenuse to a leg?
You take hypotenuse minus 1 of the legs.
No, we divide by radical 2. So this would be 1 over radical 2, and then you rationalize. So you get a radical 2 on the top and a 2 on the bottom. Same type of thing happens here. We need to look at the special right triangles again, okay? So for 330 degrees, I'm going to think, hey, if I go around 330 degrees, there's 90, 180, 270. 330 stops just 30 degrees short of 360. So that's 30 degrees right there. Now again, this is way quicker if you've just visualized it, memorized it, and stuff like that. But if this is 30 degrees, and remember, this is the unit circle, this is 1/2 because it's the short leg. This is the long leg, so this would be radical 3 over 2. And we went down, so the horizontal part, the x part, is going to be radical 3 over 2, comma, negative 1/2. And if you double check on your list, every one of these should match up when you look at that. So I'm going to come back over here and just double check and make sure. There's 135. Did we get the right numbers? There's 240. Did we get the right numbers? There's 330. Did we get the right numbers? Okay. Questions? We're good? Okay. So how are the angles 60, 120, 240, and 300 related? So don't say anything. I'm going to come back over here and we're going to take a look. So they were 60, 120, 240, 300. You have a huge hint on that because it's printed in color, and we've got a huge hint up here because it's in color. What do they all have to do with each other? How would you say it using the vocabulary we've used the last couple of days? Okay, you don't have to use the vocabulary, just tell me what you think, Zach.
They have the same numbers in them. They switch around the negatives.
Yeah, okay, I'll take that. They have the same numbers in them. So they have 1/2 in radical 3, 1/2 in radical 3, 1/2 in radical 3. They just switch what the signs are. Yeah.
They all have a denominator of 3.
They all have a denominator of, are you sure a denominator of 3? They all have a denominator of 2. They have a radical of 3 in
No,
them.
all of the radians have a.
Oh, all of the radians, yes. Okay, you're right. All of the radians have a 3 in the denominator. You're right about that. Yeah.
And then like the ones that are like directly 180 degrees from one another, they literally just switch the signs around.
Yeah, so if I look at this one right here, I literally just switch the signs around. If I look at the one right here, I literally just switch the signs around. They're 180 degrees off from each other. Everybody okay with that? What if I drop a line straight down here? How big is the reference angle? 60 degrees. How big is the reference angle? 60 degrees. How big is the reference angle? They all have reference angles of 60 degrees. So let's come back over here and let's just say reference angles of 60 degrees. And remember, reference angles and reference triangles are always drawn with the x-axis. So off to the side here, always with x-axis. Okay? Everybody good there? Okay, now, I am hoping that without looking at your notes, you know what these reciprocal identities are. Cosecant. Little hint, we always say them in the same order. Sine, cosine, tangent. So this is the reciprocal of sine. Secant. My little mnemonic device when I was a kid, I just said sec cosine. That's the way I said it in my head. I never said that out loud to anybody because they'd make fun of me, but it's related to the cosine. And of course, cotangent is pretty easy. That's the reciprocal of tangent. And then these are a piece of cake because we just take the other ones and flip them over. Those are called the reciprocal identities. Those are on your chart. The quotient identities, and if you'll remember back to when we started yesterday, we said the cool thing about what we've done here by constructing the unit circle and coming up with these identities, you can figure out every other trig function in terms of just two things, sine and cosine. That's all you need. So we figured out yesterday that the tangent was the sine of theta over the cosine of theta. And I'm going to say this at some point. There are lots of people that just say sine over cosine, and we kind of leave off the theta. That's okay to say that, but we wouldn't write that, okay? Because without plugging something in, it doesn't really mean anything. And then this is the cosine of theta over the sine of theta, okay? Can I see a fist to 5? How many of those do you have memorized? 5s, I got them all. Fist is, I got none of them. Okay, all right. Okay, not too bad. We're just starting out. Okay, it says use your knowledge of the unit circle and identities to find the trig ratios for the given angle. Sine of 135. Wait a minute. Isn't the sine the y-coordinate? And didn't we just draw a reference triangle for 135 degrees? So isn't this negative radical 2 over 2? And this is radical 2 over 2? So D, what's the sine of 135? It is, very good. It's the positive one, because remember, this is going to be the opposite side. It's going to be the y-coordinate, so radical 2 over 2. Done. Now, if you wanted to, could we look over here and say, oh, 135 sines the y-coordinate, radical 2 over 2? Absolutely you could. Your goal is to be able to get that in your head. 240 degrees. 60 degrees right here. Ooh, that's the long one, radical 3 over 2. Okay, are you recognizing these numbers? Didn't we do these in the warm-up? Cosine would be which coordinate? The x. So it's going to be negative 1/2. Okay. Tangent 330 is a little bit tougher. Tangent's a little tougher. Yeah.
Don't you just take the sine theta and put it over cosine theta?
Very good. Nice job. We do sine 330 over cosine 330. So these are numbers that we can get off the unit circle. Hey, wait a minute. The numbers that we just did up here. So the sine is negative 1/2. The cosine is radical 3 over 2. This is a complex fraction, so we flip it over and we multiply. So we've got negative 1/2 times 2 over radical 3. Those cancel. Negative 1 over radical 3. And I'm going to pick on Wilson. Wilson, what's the problem here?
The radical 3's on the bottom.
Do you remember what we call that? What's that?
It's the radical 3's on the denominator.
Yep.
So you gotta rationalize.
Ooh, very good. That's the word we're looking for. Rationalize the denominator. So radical 3 over radical 3, we're multiplying by a funny looking 1. Negative radical 3 over 3. Put a box around that, you're done. Any questions? Mason.
Couldn't the quotient identity for cotangent also be cosecant theta over secant theta?
If you want to do something funky like that, I'm not quite sure what you said, but yeah, I suppose you could. Suppose you could. Be better to do it in terms of sine and cosine now. Okay? We can talk about it later. Okay, so take a look at this one right here. This is kind of doing the opposite. This is saying, hey, up here, I gave you the angle and you found the ratio of the sides. This is saying, I'm going to give you the ratio of the sides. You tell me all the angles that would work for that. So remember, this is a y-coordinate of 1/2. So let's visualize what that would look like, and then I'm going to have you look at your chart. A y-coordinate of 1/2 would have to be a 1/2 here. And there's only one other place where we can draw a circle or draw a reference triangle where that side is positive 1/2 and it happens to be over here. How big is the reference angle? Small side, small angle. 30 degrees right here. So one of them is going to be 30 degrees. What's the other one over here?
150.
It's 150, yeah, because if we have a 30-degree reference angle, this is going to be 150 right here. So 30 and 150. Now, I'm going to grab the chart, and what we're looking for is we're looking for a y-coordinate of 1/2. Right there, right there. What's the problem with this right here? It's negative, okay? And we only wanted values between 0 and 360, okay? So you only have to find a couple of them. Let's take a look at this one. Cosine is which coordinate? The x. So let's think about this for just a second. If the cosine is radical 2 over 2, well, there's one of them. And this is kind of cool because the other one, the way you keep that positive would have to be down here. So one of them would be 45 degrees up here. Don't say anything out loud. I'm hoping you know this from common angles without looking at anything. Who's got it for us? Luke? 315. So the answer on this one is 45 degrees and 315 degrees. Everybody good there? Okay, now this one is a little bit tougher. Isn't tangent the sine of theta over the cosine of theta? We want that to be 1. What's the only way that sine over cosine could be 1? Think about it for just a second. Si, what do you think?
It's 45, 45, 90.
It does have to be a 45, 45, but the other thing is they have to be, Zach? Both positive or both negative. So let's look over here and let's see if we can find this. And by the way, did a huge favor for you, so I'm going to blow this up and make this large. Tangent of pi fourths, tangent of 45, 1. Because radical 2 over 2 divided by radical 2 over 2, they are exactly the same. And where would that happen again?
The third one.
Over here in quadrant 3. Okay? So 45 degrees and 225. So we're going to come back over here and we're going to say 45 degrees and 225 degrees because the sine and the cosine are identical there. Same sign, same number. Everybody good with that? Okay. Before I leave this, I want to erase all of these guys here. I'll remove all these annotations and I want you to take a look here. In quadrant 1, they're all positive. None of them are negative. In quadrant 2, sine and cosecant are positive. The rest of them are negative. In quadrant 3, tangent and cotangent are positive. The rest of them are negative. And in tangent 4, secant and cosecant cosecant, I'll say start that again. Cosine and secant are positive. All the other ones are negative. And down at the bottom, See that right there? That was our little mnemonic device. So our mnemonic device, which we're going to use in a few minutes, is this. All of them are positive. Sine and its reciprocal are positive. So all students take tangent and cotangent calculus. Cosine and secant. Everybody good there? Okay, flip the page over. Okay, now, we do not use, like I said before, we don't use reciprocal trig functions very often, but it is nice to be a little bit acquainted with these. So, you want to use your knowledge of the unit circle and some of those identities to figure out what the secant of 60 degrees is. So, can somebody raise their hand and tell us, if it's not on the unit circle, because it doesn't have secant on it, how do we figure out the secant of 60 degrees? Think about it for a second. You've got some identities. You've got a paper. We've talked about it. We've actually done a problem like this before. Mason.
You just do 1 over sine of 60.
Not 1 over sine, 1 over... Yeah, so remember I say cosine in my head, so this is going to be the cosine of 60 degrees. So can you grab the cosine of 60 degrees quickly? Hey, wait just a second. 60 degrees is right here. That's going to be the big side. I want the adjacent side. That's going to be 1/2. Wait, 1 over 1/2? Flip that over. We end up with a 2. There's our answer. Cotangent 330. Remember that thing we said yesterday where you can figure out everything in terms of sines and cosines?
Yeah.
What goes on the top?
Cosine.
Cosine. Very good. For cotangent, it's going to be cosine theta. Whoops. Cosine 330 on the top. Whoops. And sine 330 on the bottom. If you've got a visual in your head or you're just looking at it, it looks like this. Radical 3 over 2, negative 1/2. Cosine. Adjacent side, it's the x. Radical 3 over 2. Sine. That's the y-coordinate. That's the opposite. Negative 1/2. So I've got to take this, flip it over, and multiply. So this would be multiplying by negative 2 over 1. Cancel those, and I end up with
Radical 3.
negative radical 3. Okay, so we're going to put a box around that, and there's our answer. Okay, now, we've got a couple more that we're going to take a look at, and these are more thinking questions than computational questions. And then I'll give you your assignment, and we'll run through, and you'll see how easy this is. It says true or false. Don't use a calculator. Is the sine of 210 the same as the sine of 30? Raise your hand if you say true. Okay, put them down. Raise your hand if you say false. Okay, the people that said false, tell us why it's false. Zach, what do you think?
One of them's positive, one of them's negative.
Very good. Over here, the sine of 30 degrees would be 1/2. The sine of 210 would be negative 1/2. So they have the same number. They have the same value, but different signs. So the answer on this one is false. Okay? Those are not equal to each other. Ryan, will you pull the door shut? Cosine 135 and cosine 225. Zach?
Both of them are the same.
They are. Can you tell us what the value is?
I think it's negative square root of 2 over 2.
He's right. Okay. So the answer on that one is, whoops, the answer on that one is true. Okay. Everybody good there? Okay. I'm going to slide down here. And this is just a challenge one right here. So you do not have to do this. Okay. I think that's above and beyond. Okay. So let's take a look at this right here. And I would like you to write this down, please. All students take calculus. And here's what we want. It just says each letter on the circle corresponds to a central angle by the same name in standard position. So J represents a central angle right here, and we'll call that angle J. That's going to be the measurement for that one. And it says, circle the most specific value of the trig function using what you know about the unit circle. So let's take a look at this. The sine of A is right here. Is the sine the x coordinate or the y coordinate?
Y.
It's the y. What's the y coordinate there?
0.
0. Circle 0. Cosine of G. G's over here. Is the cosine the x coordinate or the y coordinate? The x. Is it exactly 0 or negative 1 or 1?
No.
But what can we say about it?
Negative.
It's negative. That's the most specific thing we can say about it. Don't say anything out loud. Tangent A. Luke, what do you think?
0.
It is 0. Can you tell us why it's 0?
Because the sine of the cosine is
Yep.
not.
Very good. So sine of 0 over the cosine of 0, and we already figured out this was 0. So this would have a 0 on the top and a 1 on the bottom. So it would be 0. Okay? Don't say anything. Tangent, or sorry, sine of E. I'm just going to call on somebody. We're going to risk it here. Okay, Megan. Is the sine the x coordinate or the y coordinate?
The y.
The y coordinate. So the sine of E would be
Negative.
perfect. Last one. Cosine of C. C's right here. Abby, what do you think? Cosine would be the x coordinate. So the x coordinate of C, to get to C, it would be... Very good. Nice job. Okay. Luke.
What would be the tangent of 90? Because you would end up with like 1 over 0.
Ooh, that's a great question. You would end up with what?
1 over 0.
1 over 0. So if you were right here, the tangent of 90 degrees would end up being 1 over 0. Would you take a look at your little supplement there?
Yeah, it says infinity.
It says kind of says infinity. What does it say? It's undefined. The closer you get to 90, the tangent explodes. It gets enormous. Okay? And you'll actually study stuff like that. Okay, so hang on just a second. I want to get the assignment in your hands. Would you circle the self-assessment, please?